All right. So what we want to do is we want to analyze a claim that a company has tried to lower the amount of nicotine in their cigarettes. So a certain brand of cigarette has an average amount of nicotine in each cigarette of about 9.8 milligrams right there, and a standard deviation of 1.6 milligrams. So this is their estimate for the population, mean and standard deviation. Again, anytime we make stuff, there's always variability. Nothing comes out perfect. So if you expect every cigarette to have exactly the same nicotine in it, you're incorrect. If you expect every cup of coffee to have exactly the same amount of caffeine in it, that's incorrect. Even like Red Bull cans don't have exactly the same amount of everything. It's just close according to the machine setup. The company produces these cigarettes, claims that it has now reduced the amount of nicotine. So they claim the nicotine should be less than that 9.8 milligrams. Here, we've been asked to analyze some evidence that a sample of 47 cigarettes has a mean amount of 9.473 milligrams. Assuming the given mean and standard deviation have not changed, so that means we're going to assume that this is still the population mean there. We want to find the probability of randomly selecting 47 cigarettes with a mean of 9.437 or less. So in this situation, I have to identify what's the population information, what is the sample information, and then I have to compare the two of them to see if anything has changed and then make a recommendation based on that. So let's do it. So some things to consider, population in this case would be all cigarettes produced by this company. So every situation you get to kind of reflect, what is the population we're looking at here? And it's always a little bit different, and usually you kind of make it as big as you can. We're talking about a single company here, not all cigarettes produced, but just this company's cigarettes. So all cigarettes produced by this company. What is the parameter of the population we're trying to identify? Parameter. The parameter in this case is the mean amount of nicotine. So average nicotine in cigarettes. And that's for all of the cigarettes they produce. So if we collected every single cigarette they ever produced and we measured the nicotine in each one, added those all up, divided by how many, that's the population parameter. Right? So it's not possible to make that happen. So we have to estimate with a sample. So that's the population, that's the parameter. What's the sample here? Sample is 47 randomly selected cigarettes. And what is the statistic? And remember, a parameter is a measurement from a population. A statistic is a measurement from a sample. The statistic here would be the average of these 47 cigarettes. So average of this sample of 47 cigs, which happens to be 9.473. Let's make a note about the population parameter we have. That one is 9.8. Now, would you agree, like clearly 9.473 is less than 9.8, but is it less enough given that it's the average of 47 cigarettes? Now, these 47 cigarettes, right, some of them had more nicotine than 4.73, and some of them had less than 4.73. On average, is this far enough below 9.8 to be significant? Or could this just happen randomly, even if it was supposed to be 9.8? So we're just going to kind of test their claim here. Let's see. So that's some stuff related to the beginning of problem F in the application. I want to start drawing a sketch of this to figure out what's going on. So new page. So again, we have nicotine average in cigarettes. And some important information here. Let's stick with red for a minute. We have a population mean. Mu is the population mean. That's the 9.8. We have a population standard deviation of, I forgot what that one was, 1.6. So this is, again, population information. Next thing we need to consider is we have the sample information, and then we have to talk about the sampling distribution. So there's three different things going on here. We have the population, we have the sample, and then we have a sampling distribution. And those are three different things, but they're related. So for the sample, all we know is X bar is 9.473? Yep. 9.473, and we also know N is equal to 47. Yeah. 47. So that's the sample information. And next, we have the sampling distribution. What is a sampling distribution? It is a distribution or collection. Distribution of sample means. So in other words, we take tons of samples, all of size 47, and we just find the mean of each sample and we graph all of those means. That's a sampling distribution. It's not the population, it's not an individual sample, it's thousands and thousands of samples. Now at the moment we only have one. So the mean of a sampling distribution, so that would be mu with a subscript X bar, that's always going to be approximately equal to the mean of the population. So in this case, that's going to be a 9.8. The standard deviation of a sampling distribution, X bar, is always going to be approximately equal to the population standard deviation divided by the square root of the sample size. And so in that case, we would have to take our 1.6 and divide by the square root of 47. So I need that value from my calculator. And I think I'm going to put all this in the spreadsheet right now. So, new tab, and this is number 17, but it's like the application. I'm treating it the same way. We have nicotine average, and so then we have mu, and I think there is a way to get that symbol into a spreadsheet by inserting, do we have symbols here somewhere? No, that's not it. You know what I mean. That was the 9.8. We have sigma from the population. That was what, 1.6? Sorry. Yep. So that's the population stuff. So let's just make a note, population stuff. And then we'll do sample stuff. So let's skip a line, sample. For the sample, we have, let's call it X bar. We could call it the mean, and that was 9.473, I believe. And we have the sample size, which was 47. And then we have the sampling distribution information. So sampling dist. And for that one, the mean is the same as the population mean. So I can just click equals and click on that number. Or I could have retyped it. And the STD, which is also called the standard error. So standard error just means what's the standard deviation of your sampling distribution. And that is, for a mean, always the population divided by the SQRT of the sample size. So I get 0.233 if I went to 334, if I went to 4 decimal places. Let's put that in the notes too. And this is approximately 0.2334. Did I read that right? 0.2333 and then an 8. Yeah, okay. So that's the standard error for the sampling distribution. Okay, making progress. Next, I need to draw a picture and then figure out how to do a calculation. I'll also whip out stat key on this. So I need a new page for that. So again, this is average nicotine. And let's draw our best bell-shaped curve. Hey, that's not bad. In the middle goes what? The mean of the sample, the mean of the population. Anybody remember? Please, somebody engage me. I'm awfully lonely here. Mean of the sample or mean of the population goes in the middle of a sampling distribution. No, it's actually the mean of the population, but thank you for participating. Appreciate it. Yeah, so the central limit theorem says that the mean of the population goes in the middle. Now, we hope the mean of the sample is near if it's a good sample and the mean of the population is correct. So we're going to put the 9.8 in the middle. Now, this is a sampling distribution, so average nicotine sampling distribution, which means I have to choose the correct spread for this, and the correct spread for this is sigma over the square root of n, and that was that 0.2334. Now, for ease of drawing it on the screen, I'm just going to say that's about 0.2, because I can easily add that in my head to 9.8. So if I mark off like 1, 2, 3 standard deviations, then adding 0.2 to that's going to give me about 10 here, 10.2, and about 10.4. I'm going to mention z-scores here because we're going to need them later. Z-score, remember, come on, pen broke. There we go. Z-score just counts standard deviations. So as far as z-scores go, this is the middle, so that's 0 for a z-score. That would be 1 standard deviation to the right, 2 to the right, and 3 to the right. We can also go the other way. We can make marks at -1, -2, and -3. And a z-score, again, just counts standard deviations. Doesn't ask about that in the application, but it's something I thought I would bring up. It was in the reading. And we'll use z-scores more next week. Let's go back to blue. So measure 1, 2, and 3 standard deviations below. So that would be subtract 0.2. So that would be what, 9.6-ish and 9.4-ish, and then about 9.2. And again, I rounded that so severely just so I could easily make those calculations. All right, so that's what my sampling distribution looks like with the way it's spread out on the bottom. It's going to be narrower than the population standard deviation because we had to divide by the square root of n. And the way to think about that is why is a sampling distribution narrower? And the reason is we're graphing averages, which means for every sample there was a min and a max, but those get averaged into the center, right? So we lose those extremes. Since we lost those extremes, right, there's not much spread anymore. So consequently, a sampling distribution, it will always have a narrower standard deviation, a smaller standard deviation, and a narrower graph. And the bigger the sample size, the narrower it gets, which is kind of wild. Okay, so I think I'm ready to answer their questions. So let's go back to the question. So assuming that the given mean and standard deviation have not changed, right? That's why I put the 9.8 in the middle here, because they told me have not changed there. Find the probability of selecting 47 cigarettes with a mean of 9.473 or less, right? And they have a less than there too. All right, so let's go to the notebook again. So next they're asking me to find what is the probability that another sample has a mean that is less than that one we found, 9.473 milligrams, knowing that the population should have a mean of about 9.8. Okay, and this is what we call a p-value last week. All right, so that's what they asked about. This less than right there means I'm doing a left tail in stat key. Nice thing about a left tail is spreadsheets can do left tails really easy with the norm dist. So either I'm going to go calculate this in stat key, and in stat key I'm going to use the theoretical normal, or I could use a spreadsheet to calculate this. I'll do both ways. And the spreadsheet would use the norm dot dist formula, and the norm dist formula will calculate probabilities for us. And it's freaking out here. And it wants to know, what is the x value you're concerned about? For us, that would be x bar. What's the population mean? What's the population standard deviation? Ours is a sampling distribution. And then it's always a 1 or the word true at the end there. All right, let's do it. Oh, let's draw that in the picture. So where does 9.473 fit on my picture? And your version of this problem will have slightly different numbers. And same thing on the application. Everybody has slightly different numbers on the application. 9.473, it's kind of close to 9.5. So that would be around here-ish, 9.473. And so I want to know what is the probability of getting another sample of 47 in this region, with an average in this region over here. And according to the empirical rule, I think that's going to be somewhere between, let's see, be somewhere between 16% or 2.5%. So I'm going to guess that's like 7 or 8% is my guess, looking at it. All right, let's do it. So calculator time. Let's do this one first. So I want to find the probability that x bar is less than 9.473. And so that would be equal to the norm dist, because it's a left tail. I don't have to do 1 minus, that's a right tail. And then enter the value we're questioning. Enter the population mean, find the correct standard deviation. So we have to use the standard error in this case because we have a sample. So that's 47, and then true or 1. Okay, so according to the calculator, it's about 8%, which was in my ballpark guess there. I was thinking like 7 or 8%. Stat key, I have to enter this value here, the 2.33839, whatever, and I would put in at least 4 decimal places. I think I'll go for 5 today. And remember, this is our population mean. So in stat key, I want the theoretical normal distribution. So that's theoretical normal. And I need to edit my parameters, put in the correct mean, put in the correct standard deviation. So 0.23338 is the one I'm going to go with. And then I have to do a left tail. And down here goes the 9.473. And I get 3 decimal places, 0.81%. Sorry, 8.1%. 0.81 as a decimal, which, yeah, if we rounded that to the 3rd decimal place, there's the 0.81. So the spreadsheet gives you more decimals if you happen to need them. Okay, so what does all of this mean to the cigarette manufacturer? So let's look back at our situation. Notes, please. All right, so let's make a note. We found that that probability here was about 8.1%, right? So that's this calculation down here, 8.1%. So I'm going to write what that means. What's the interpretation? Oops, new page. There is an 8.1% chance of finding another sample of 47 cigarettes with an average nicotine, spell it right, average nicotine level of 9.473 milligrams or less, right? When we were expecting the average to be 9.8 milligrams, right? Because they said assume it hasn't changed and then see if this seems like a remote chance. Oh shit, come on, pen. So is 8% unusual? What's our cutoff rule for a situation for unusual? We usually use 5%, right? Is kind of the default, and it's a life or death thing, then we might want it lower. And if it's like really trivial, we might even choose 10% for the cutoff. You know, nicotine is a pretty addictive substance, so I wouldn't, 5% is okay, and it might even go less than that. So if they really believe that they lowered the nicotine, there's an 8% chance of randomly selecting 47 cigarettes. That's like common. That's not uncommon. So it looks like they didn't lower the nicotine. Okay, so this is not unusual. It's not unusual to find 47 cigarettes with an average of 4.73 if it's supposed to be 9.8, because it came out to 8% chance of that happening. It's not unusual, so it seems the average is really not lower than 9.8 milligrams. This is not compelling evidence, okay? So I'd say, hey, you guys didn't do a good job of lowering the nicotine level. We think it's still about 9.8 based on this sample. This is a good random sample. So you guys better go back and figure out how to lower the nicotine if you really want to make your cigarettes less addictive and less dangerous. So you have a similar thing to look at in your application. So let's kind of bring it up and make sure I got all the key points Mercedes was asking about. I think I addressed just about everything in that part F there. And I'm going to type this in just to get it done. So this was, they want decimals, so 0.081. Based on the results above, is it valid to claim that the amount of nicotine is lower? And the answer is no. So that 8% is too high to have this be just a purely random chance. So it doesn't look like they did a good job of lowering nicotine. Okay, so let's go take a look at the application. And this is kind of a true story, the application. The sample numbers are made up, but the details about the situation are true. So the amount of contaminants that are allowed in food products, FDA controls that. So all kinds of food products are tested to make sure they're safe for human consumption. And milk, it's got, you know, some cows are healthy and some cows are not healthy, and there's going to be a certain amount of other stuff in the milk. And somatic cells are basically pus cells in the milk. And in 1 cc, so that's a cubic centimeter or a milliliter, which is like 1/3 of a teaspoon. So it's a little, it's more than a drop, but it's less than a teaspoon. There can be an average of no more than 750,000 pus cells. It seems like a lot. It's kind of making me not want to have any milk. I don't drink milk anyway, but if it's in milk, it's in ice cream, right? Oh, shit. So then you're told the standard deviation is 111,000 cells. So there's some spread in that amount. You get a sample of, and each of you will have slightly different numbers here, but the 75,000 is the population mean. So that's kind of like this cigarette problem. And then you're given a sample mean. And so you got to differentiate between the population, the sample, and the sampling distribution. And then there's a few questions down here that ask you to think about that. And so this part right here is kind of like me answering the nicotine question. And then I ask for some more details down here. So what's the population? What's the parameter? What's the sample? What's the statistic? We've been talking about that for the last few weeks. We started talking about populations and samples in week 1. And it's still a hard thing to wrap one's mind around what's the difference. And again, I did address that for the nicotine problem. You're going to have to address it on your own for this problem, right? So identify what each of those are. And then I want you to kind of write it up essay style. So you don't have to write the answer to A is, the answer to B is. Just kind of put it all together in a couple of paragraphs if you can. But if you're dying to go 1, 2, 3, 4, 5, 6, 7, 8, go for it. But an essay would be lovely here from you. That addresses all of these points. So you'd have to take some notes first and then write it down. Okay, so then part D above is that probability, right? And notice in my notes here, that was the last thing I did, is after I calculated, I drew my picture, I expect you to draw a picture like this, make the calculation, and then explain to me what that calculation means, okay? So it's going to be kind of similar to this, but your outcome may not be exactly the same. It's a different situation. And then is it unusual or not? So you can say, give a recommendation to the FDA, like, hey, yeah, it looks like this sample's within reasonable limits according to your claim here. Or, oh man, I think there's a little too much pus cells, FDA, you better start helping people get healthier cows. So you're gonna have to decide what your situation is here on that and make a decision and advise the company. So kind of like me saying that cigarette company, no, I don't think you did a good job of lowering nicotine. You're gonna have to go back and figure that out again because this sample is not unusual. Okay, so I kind of roughed out my answers to that. So the next thing I would do to turn this in is I would take this stuff here, my picture, and this conclusion here, and just write that up in 1 or 2 paragraphs would be the last step there. And then to get your picture in there, you could draw it on a piece of paper, take a picture of it with your phone, and then send that to yourself, and then you can use the upload image to then go get that off of your computer once you send it to yourself on your computer. And so you can go grab it and stick it in there. So I don't have that right here, but and then that'll put the picture right inside. So like you could put it in between 2 paragraphs if you wanted to there. So that is your goal toward the end of the week. Make sure you do the practice first. Make sure you do the critical thinking first, and then do this last. All right, so I'm gonna stop that recording.